Harvey. I'm a graduate student in the Environmental and Ocean Science Department here on campus. And myself and my co-conspirator grad student, Kate, standing over there.
Hello.
Really want to welcome you guys and thank you guys so much for coming. It's an awesome turnout, so I'm just really happy to have you guys here. So, changing the climate of conversation. That's why we're all here. We're all brought together in this space. So global climate change is exactly that. It's a global issue. In 2015, 175 countries signed the Paris Agreement, which is a United Nations framework convention on climate change, recognizing the need for mitigation and adaptation of greenhouse gas emissions. This is a global issue of great concern. Globally across the globe, we're seeing that a lot of countries are actually already experiencing a lot of climate change effects, and we're seeing climate change refugees in different locations globally. So however you want to see it, the US is a global leader in a lot of different sectors of the world. However, I would not argue that climate change is one of those. In 2017, President Trump announced his intent to pull out of the Paris Agreement. And across the board, environmental regulation agencies on the federal, state, and local levels have been removing climate change rhetoric from their documentation. So what we as scientists, concerned citizens, and local activists, what we found is the most proactive and immediate response to these triggers is actually what anything else is important, is communication and conversation. So each of our wonderful panelists before you guys, I'll introduce them in a second, will be showing their perspective, some techniques and strategies that they use in order for us to enter this space and invite more of a positive and effective communication for this global issue. So I just want to introduce our panel before they all speak. Dr. Michel Boudrias is an associate professor in the Environmental and Ocean Science Department, so he'll be bringing you guys kind of the science perspective. Reverend Dr. Christopher Carter is a professor in theology and religious studies, and then Christiana DeBenedict and Leah Bruce are both from the Climate Education Partners here on campus. So I hope that their perspectives will bring you guys something really wonderful, and that we can have a really good discussion afterwards. Thanks. Michel?
I don't like podiums. Well, thank you again for coming to this event. We are always excited to talk about ways that we as citizens, you as students, and as adults and faculty can be engaged in making some important decisions. And I think today you'll hear different perspectives on how we need to get the information out, how we need to present it, and how we need to deal with the realities of what is the world around us affecting how we present important information. So what I'm going to do is I'm going to use a presentation I gave a little while ago with some modification on how we talk about climate science in a world of alternative facts, in a world where things are a little bit different than they used to be. Or not.
Yeah, you got to point out the thing.
There we go. So when scientists talk about climate change, they use a lot of graphs like this. And for the scientists, that seems to make a lot of sense. But oftentimes, these graphs are not as simple as you might expect, because this is not a change in temperature, but it's a change in the anomalies of changes in temperature. It's in degrees centigrade, so how many of you use degrees centigrade on a regular basis? Right? How many of you typically don't use that? Do you think our political leaders understand the concepts of degrees centigrade? And yet, that's how we go out there and present the science.
Michelle, I think your microphone is off. We can still hear you great though.
I'm sure you can hear me, but you want it on tape. So we use graphs like this, which talks about CO2. This is a graph from just a few days ago showing that we have reached over 400 parts per million in carbon dioxide. It shows the science. It makes it very clear. It shows the temporal perspective on it. But again, we're talking about parts per million, and we're talking about the science in a way that gives us important information, but doesn't necessarily communicate the message that we're trying to get across. Now, I will say that I'm going to start off with the fact that there is no debate, and this is one of the problems in the communication space. 97% of scientists believe that climate change is happening, it's real, and it's human caused. The three scientists who are in gray or red, and I'll present this from my friend Dr. Sheehan, most of them are physicists or astrophysicists. But because they're looking at, not that they don't believe it's happening, but they're not sure of the certainty of the data. So there really isn't an issue as far as the scientists are concerned. And I will tell you, getting 4 scientists to agree where to go to lunch is hard enough. Getting 97% of them to agree that something important is happening is really quite an amazing thing. Okay? I want to put into perspective why some of this communication is challenging. So this graph presents in the center in gray and in blue the science of climate change. In gray, the processes themselves, CO2, methane, nitrous oxide, the greenhouse gases that you hear affecting the planetary cycling, this in turn affecting ocean circulation and melting ice caps. But the real message of this graph is to point out on either side of the science the amount of human impact and human connection to climate change. In orange are the types of human activities that impact the science and of science of climate change. Deforestation, change in land use, agriculture, burning fossil fuels. And to the right, the impacts of climate change on humans all over the planet. Sea level rise, impacts on farming, disasters like we had last year, and environmental refugees. And for you to know, we think of environmental refugees, it must be happening somewhere else. We have US environmental refugees, people from Louisiana who have lost their land completely. In fact, one of our alums who was going to be farming that land no longer has land to farm, which was in his grandfather and his family's, because it is now gone. This is a reality, right? If you look around the world, the impacts of climate change are pretty clear. Just to give you a world tour, that's Australia at the top. In 2012, they had to add a new color to their temperature map, the purple in the middle, because they had never reached 50 degrees centigrade before, and now it's a common temperature for the last 4 or 5 years. You see floods in India, massive sea level rise in South Africa, floods in Vietnam down in the cities, right in the middle of cities, and in countries like China or the US, an area of the country that's completely in drought, another area that's completely flooded. These are realities that we see around the world, and we've been seeing this more and more. For those of you from Houston, or those of you in that area that saw this year, this is what happened just less than a year ago. Now, the problem with scientists, however, is we want to convince you with our data, because that's the language that we use. So we use graphs like this, where we point out the temperature is going to change a lot. In 2081 to 2100, it'll be all red. It's very clear it's going to be much warmer. Or there's going to be a lot of changes in precipitation, where there'll be a lot more rain in the polar regions and the tropics, right? So first of all, how many of you know what you're going to be doing in 2100? Is this a year that connects well to you? Yeah, you and I know, but that doesn't count. We'll be dead, which is why we know where we're going to be, right? So one of the problems we use is we need projections. We need to think long-term in data, but we as humans don't think long-term. We don't think of what's going to be like. I'm sure you're not thinking 25 or 30 or 40 years from now in your life. These graphs, believe it or not, are from the science of the International Panel on Climate Change for policymakers. This is actually the simplified diagrams chosen to instruct the policymakers. By raising your hands, how many of you think that your local politician is going to be able to interpret these graphs? I figure that many, right? So this is how we think. Look, it's pretty clear. It goes up, maybe some graphs, I have some error bars in there, or maybe I'll use this one, because this one has a lot more information, and it's really important, and there's a lot of really important words like albedo and radioactive forcing, and we don't know what those terms really mean. We do, me and 17 of my friends, right? So the scientists speaking to scientists use this language. What we have to get away from is find a better way to speak to the general public that is still getting the basics of the science involved, but not the presentations we use for scientists, right? I'm going to skip a few. This is getting better because it's using infographics on things that might be important, but it's a really busy diagram using every state and every region of the country. So what happens? What happens to the scientists? Well, first, you know that if you don't understand, the best way for me to explain it to you is I will talk really, really loud and much more slowly, so then you'll understand the math, right? Or maybe I'll dumb it down, which is an insult to your intelligence. And in our project, and you'll hear more about that from Leah and Christiana, we are talking to elected officials, CEOs, community leaders, very smart people in their own right, and dumbing it down is actually an insult to their intelligence, and they will not listen to you anymore because it doesn't work. But it's how scientists tend to think if we want to bring it down. Or we'll just basically give up and ignore the people who don't agree with us. Okay, so we don't want to do that. Oops. Now, here's the world of alternative facts. Why are we out, you know? There we go. I think so. Communication is key. Okay, so this is one of my favorite memes. All right. But believe it or not, as funny as this is some of the contrary evidence that we are dealing with right now. There are decisions being made that say climate change can't be real because God would not do that to us, and humans can't be the ones affecting the planet. Okay? We have this man who's a director of the EPA who says scientists continue to disagree, that's wrong, about the degree and extent of global warming, that's wrong, and its connection to the actions of mankind, that's wrong. That debate should be encouraged, yes, but not about data. In classrooms, public forums, and the halls of Congress, it should not be silenced with the threats of prosecution. The only people threatened, by the way, legally, have been the climate scientists, to be clear. And dissent is not a crime. That is correct, except if you're using different facts, right? Someone who was part of the cabinet to plan who should be looking at the science keeps saying, every interview I do when I'm asked about scientific issues, I say I'm not a scientist. I just keep giving the informed layman's perspective supported by the American petroleum industry and other people like that, right? That is, the argument I am not a scientist should therefore let you know that maybe you shouldn't listen to their analysis of the science, and yet in this case they're using that as a tool to talk about it from that perspective. There's also other ways to deal with it. You can turn around and say CO2 is really good. It's the elixir of life. It's great for plants. The more CO2 we put in the atmosphere, the more plants we'll have on the planet. It may be good for agriculture, and it'll be really good for the plants. The answer to that question is yes, it's very good for plants. And from a planetary perspective, the plants are very happy. From a human perspective, not so much, right? Now, this person who's viewed as an expert and has testified multiple times in Congress has a degree in what science, do you think? Oceanography?
I said bullshit.
You're correct. Well, he does have a degree in that. He's got a doctorate in that.
Exactly.
But what he has a degree in is in business. No science at all, not even at the undergraduate level. Maybe one class so he can pass his core, right? More than that, however, that's problematic in this world of communicating science is the fact that we have some very smart marketing and some very smart design. So here on one side is the actual report by the government. It's required every 5 years by law. Global climate change impacts in the United States. You notice the color. You notice at the bottom the graph actually shows long-term temperature trends showing global warming in the last decade. The one on the right was put together by the Cato Institute. Notice that it's called an addendum, not a correction. And what they did is they designed the exact same report, the same colors, the same organization, and they say, here's some stuff the scientists haven't told you about, written entirely by non-scientists, to be clear, and their graph, notice, shows no global warming. That's because they used 10 years worth of data and stretched it out and said, well, in the last 10 years it hasn't been warmer. Well, it has been, because that would be the end of the last graph. It's true that in the last 10 years it hasn't been that much warmer because it's been the last warmest years ever. But they're 5 degrees, 3 degrees warmer than anything else. I added this one. This came out yesterday. This is now the Department of the Interior, where they say we are not censoring science, and this is a paragraph from the report where they're censoring science, and what they're removing is all the words human impacts. We are currently in a place where the communication of science is being controlled by non-scientists. So I gave you the example of the scientists not quite doing it the right way. Too much science, not really good communication. But now the flip side is we're actually using data that are not correct, and we're also not having scientists make the decisions. So how do we solve that issue? Well, there's been some efforts in the last decade or so to put some groups together to think about ways to do a better job of communicating science. It's been funded primarily by the federal government. Several different groups have done this. I'm going to focus on the latter one here, the NSF-CEP. About 10 years ago, the National Science Foundation realized that communication of climate change was being done primarily by scientists trained to speak to scientists. And what they needed is an interdisciplinary team of people who could understand communication in a different way. The team was required to have climate scientists, educators, policy people, specialists in communication. We are one of the projects that was funded. Climate Education Partners, you'll hear a little bit more about it from my team members. The groups did different things. Polar focused on the Arctic, CUSP working on museums, Gnocchi on aquariums and zoos, and the last two on K through 12 educational models. What I want to focus on is our group, which was put together in 2007. It includes 4 faculty from the University of San Diego, Dr. Yin and myself from our department, a climatologist and oceanographer, and 2 faculty from the Energy Policy Initiative Center who are working on how to bring this in from a practical perspective, and now, of course, a whole team. 2 psychologists who were at Cal State San Marcos and UCSF who think about how people learn about climate change and science in general. High-end climate scientists at SIO, and then a community partner that worked with leaders and other groups, and a specialist in communication. And we changed the way we talk about climate change. So let me rapidly hit the bullet points of how you might do it differently. The first thing that's really important to do is connect to you and where you are and what's important to you. So what is this image to you? Where's this?
Vacation.
Home for those of you who are from San Diego, right? This is the iconic San Diego image. This is great when I give a talk in Cleveland in the wintertime, Chicago where it's 20 below, and I just left this yesterday, right? But what does this tell us? It tells us that in San Diego, we're connected to the outside. This is part of who we are. It's natural for San Diegans to be connected to the rivers, the mountains, the beach. It is part of our quality of life. It's something we need to think about from our quality of life perspective. But our quality of life is actually being affected by climate change. One of my favorite photos, this is a picture of sea level rise bringing water right into the meeting room at the La Jolla Beach and Tennis Club. But the reason why it's my favorite picture, this is a meeting of the Southwest Regional Scientist Group studying sea level rise and the impacts on structures, and the water went right into their meeting, right? So this is happening in our backyard. And it turns out that in San Diego, people are very concerned about climate change. We did public opinion surveys. 85% of San Diegans are concerned about climate change. San Diego is a conservative area, and yet we are connected to the outside, so it's not a political ideology. In fact, we are more connected, more concerned, and more understanding that it's affected by humans than the national average in San Diego. Why? Because we're concerned for future generations. We're concerned about the next generation. It was the #1 thing when we asked people, who are you concerned about? Right? Number 4, by the way, was the oceans. Not only that, in San Diego, it's not I have to choose the economy or the environment. It turns out that 77% of the leaders in San Diego think that we could do both the economy and the environment. That is, we should be the leaders in that space. Now, most fascinating to us, and part of what you'll hear what Leah and Christiana are going to talk about, is that when we did our first survey of the who's who of San Diego, we asked them, are you personally concerned about climate change? 90% of our leaders, more than the general public. I'll remind you, we are a conservative area, military, businesses, and yet they were all personally concerned. However, if you ask them, do your peers concerned, only 10% of their peers were concerned. Why? Because we're not communicating, right? It's one of those topics. You don't talk about sex, politics, religion, and climate change, right? Especially in conservative circles. So how do we get involved? We start talking to people one-on-one. It's not just a lecture on science. We need to work with them individually. So I worked with people at the port, for example, that were putting together their climate action plan, and some port commissioners wanted to include climate change, and some did not. And so they were asked to meet me for lunch, separately, by the way, because they didn't want to be at the same table. So I met with 2 different people, and we started talking, and we talked about what's important to them, and the data that they need, and how they analyze their data. And these one-on-one interventions, these smaller connections, this connection to what's important to you, led them to include climate change in their climate action plan and win a national award. San Diego as a region is a leader. All our cities have greenhouse gas inventories. More than half of them have climate action plans. The city of Chula Vista has won a national award. The Port of San Diego has won a national award. There are several universities involved in town. And the Climate Collaborative, which is a unique organization that has academia, policy people, and practitioners all working together, is centered here. So what we did is write a report to get leaders to understand their importance. You will notice this does not look like your typical scientific report. It's people pictures. It's leaders that are pictured. And I will tell you, some of the leaders didn't want to be there because they were concerned what their peers would say until this became really popular, and then they kept calling and saying, can I be on the next one? Because I really wish I was on this one. But these are all recognizable San Diego leaders. And our approach was totally different from the typical science or the typical non-science, which was first, make the science local and regional and make it important to you. It's not that you may not care or care a lot about polar bears, but in San Diego it's not going to affect you. But it will affect you if I tell you that the beach is going to be gone. It will affect you if your building is going to disappear, right? We used infographics to communicate science, not those complicated scientific graphs. We use social psychology to connect to people's way of being. They can do something about it. It's part of who they are. It's actually part of their values. And we focus specifically on community leaders, these key influentials. And that could be anything from a group of mothers who are important for their kids, to religious leaders, to tribal leaders, to CEOs, to political leaders. And of great importance to the messaging, it's a message of hope, not a message of gloom and doom. What can you do about it? Because we're all going to die is not a good message. It's going to destroy everywhere you live is not a good message. This is what's going to happen. Let's do something about it is a way of getting people engaged. So who are the leaders? For example, the mayor of San Diego is there. Todd Gloria, to his right, is a USD alum, by the way. And Todd is now a state legislator, but was the interim mayor and the president of the city council at the time, a Republican and a Democrat. Jerry Sanders, now chairs Chamber of Commerce, was a police chief, was a mayor, a Republican. Not a political issue. It's an importance to San Diego issue. Convention Center, the Farm Bureau, the Regional Quality Control Board, these are all people that have influence in San Diego. The other thing we did is we very carefully crafted our work. One page is about science, one page is about the impacts and what people can do. The science page, you will notice, is not full of complicated graphs. It has 3 or 4 bullet points, because people remember only 3 or 4 important things when they get to talk about things. We have a quote from a scientist who says there's legitimacy to this perspective, and we have simple graphics that you can use and understand no matter what your degree of education is and what your field is. By the way, everything's color-coded. Everything is set up with certain perspective. Oh, by the way, the other page would be a quote from people who are affected by water in this case, so the Regional Water Quality Control Board and the farmers, right? So every one of them has a symbol. We focused on the impacts that are only important to San Diego. So if we did this somewhere else, we'd have to have different impacts. Right, so what did we choose? Water, coastal flooding, not sea level rise. So why didn't I use sea level rise? Any ideas? How much sea level rise is there? Right, short term. Sea level rise is going up by a few millimeters per year. You go, well, so my toes are wet now. No biggie, I don't need to worry. Coastal flooding is your house is going to go in the ocean soon. So we need to think about how people are going to respond to the terminology. Wildfires, we use nature's benefits. For the ecologists in the room, that would be ecosystem services, which is jargon that we use, but is not used by the general public or by people making decisions. And we used health because that affects everybody. Right? And the driving factor for all of this is temperature and precipitation. And these are the kinds of graphics we use. Notice, no graphs on anomalies. It's in degrees Fahrenheit. And we picked 2050, because that's not that far away. That's 30-something years away, and you can kind of put that into perspective. And it says that roughly it's going to be 5 degrees warmer. It's not that I don't have error bars. It's not that we don't have the data, but if I put a graph with error bars, you're going to go, oh, it's 4.8 plus or minus 1.6, so maybe it's not going to happen, so I don't need to worry about it. You want the science, it's available on the website. See that? But what we talk about is how do we get the door? How do we get in the door to talk to you, right? We talk about precipitation. There's going to be 16% less rain within the next 20 or 30 years, but 8% more floods. For those of you who are in San Diego, in the summer of 2015, in July, on one weekend, we got 2 inches of rain. In that weekend in July, we typically get 0.02 inches of rain. So in one weekend, we got 100 years worth of rain. That's what we mean by more floods in time. Coastal flooding, connecting to terminology that you understand in inches, not in centimeters or meters or millimeters. And then examples and things that you can do. not just tell you about the science, but give you an idea of the kinds of solutions you can do something with. So, how do we tell our story? Our story is that in San Diego, we love our quality of life. It's a great place to live. We would like to continue this for the future, but we are threatened by climate change. We need to do something about it, and the way to do it is to work together. And we need to do it now and for future generations. Now, I have now told my story. I'm going to turn it over to Dr. Kirby.